In this video, I will explain another very important problem in machine learning called model selection problem. Model selection is very important concept. So let's imagine there are 4 training data points. So here this axis present input x and the y-axis present corresponding output y. Right. So let's assume we have several options to fit these 4 data points. We can use degree 1 polynomial alpha 0 plus alpha 1x, degree 2 polynomial and so on. So we can define degree m polynomial and forth. Okay. So among these many polynomials, we need to choose one specific polynomial model to fit our training data. Okay, so in general, we have many data points. Let's say there are n number of data points, and we usually train our model using this loss function. Because this is regression problem, we can use one of regression loss function, and here I will use the mean squared error loss function like this with degree m polynomial. And the machine learning process compute the loss value with parameter alpha 0 to alpha m and train the parameter by minimizing the loss value L. So when we train our model, degree m model, as we increase the degree of the polynomial, basically the loss value will decrease because we have more degree of freedom, we have more parameters. We can fit the training data more accurately compared to the lower degree cases. Then maybe we can conclude that let's use a super high degree polynomial function to make our very accurate predict. Is it true? No, this is very bad strategy. Essentially, in machine learning task, our main goal is not minimize training loss. We want to minimize test loss. Test loss means we want to predict the output of unobserved input rather than already seen data point. So in the previous example, we have 4 training data points like this, and we can train our polynomial function to fit the training data very well. But essentially what we really want is we want to predict some point here we didn't use for training from the training data point. Okay, so very small training loss does not imply the very nice test loss. Okay, so this is the very important property when you design a machine learning algorithm. So when you draw a graph, loss and your degree of polynomial, or in general we say complexity of your model or capacity of your model. When you increase degree or capacity of your model, you can observe this kind of curve. You can decrease the loss as you increase the degree or complexity. But this is not our final goal. We really want to minimize the test loss. And when you plot the test loss, the graph looks like this, U-shape. Essentially, when the degree of your training algorithm is very high, your capacity of your algorithm is very high, there is huge gap between training loss and test loss. And this phenomena is called overfitting. And this gap is called generalization error. We have to deal with this generalization error. We have to minimize the overfitting as well. Not only the training loss, but also overfitting we have to deal with. Okay? And another very important message from this graph is increasing the complexity does not always give you better performance. We have to find a very nice complexity point that can give you very nice test loss.